y equals 4x squared minus 5x cubed, and dx over dt equals 2. Find dy over dt when x equals 4. So, what I want you to recognize here is this derivative structure that we've seen already when we did implicit differentiation, right? And with the implicit differentiation, we always did dy over dx was always what we did, right? We differentiated with respect to x. So when we differentiated y, we had to put dy dx. When we differentiated x, we just did the derivative, right? Now we're going to get dx over dt, dy over dt. We want everything with respect to t, and obviously there's no t's in the equation. All right? So what I want you to understand is the equation over there, y equals 4x squared minus 5x cubed, is based on functions of time. All right? Things that are changing with respect to time. So typically when you see an equation involving related rates, we're talking about things that are moving. All right? A car is going at some speed. A balloon is floating up at some speed. A boat's going at some speed. That kind of stuff. Maybe a spotlight's moving at some speed, and then it's creating shadows that are moving too. All right? So what we're dealing with is every variable we're going to get in these problems is going to involve something that has a rate, a speed. So looking at this, there's no context to this problem. They just give us an equation. They give us some over dt stuff, and they ask us to do this. This basically is where you want to be in every single problem. Every word problem you want to get to a point where you have an equation, you have something you know about the speed of one of the objects, you know the specific position of one of the objects, and you're trying to find the speed of the other object. That's kind of where you want to get to every single time. And sometimes there's several, there might be 3 different speeds going on. So you want to know 2 speeds, all right, and you're looking for the 3rd speed. In general, however many things you know, you're allowed one more variable than that. So I know one speed, dx over dt is equal to 2. So I'm allowed to have 2 variables in this problem. So once you get to the point where you have the equation, you know exactly how fast one of the things is going, you know exactly where that or something is, and you're trying to find the other thing. Once you get to this point, now you're ready to do the problem. And you do the problem by implicit differentiation with respect to t. Alright, so if I take a look at my equation, y equals 4x squared minus 5x cubed, and I differentiate everything with respect to t, the derivative of y is 1, and I'm going to put a dy dt on it. Because y is not t, so I have to establish that it's going to have that extra little piece to it. The derivative of 4x squared is 8x. X is not t, so I have to put a dx over dt on that. And then minus 5x cubed is minus 15x squared. That's the derivative of that. That's not t, so I'd put a dx over dt on it. And if you look at the construction that I've made out of this equation, so again, this is my original equation given to me, differentiating each object with respect to time. Y and x aren't t, so I had to put a dy or dx over dt on each specific term. Look at what's left over. 1 is a number, dy over dt is what I'm trying to find. X equals 4, dx over dt equals 2, x equals 4, dx over dt equals 2. The only thing I don't know is this dy over dt, so now I'm going to substitute everything into this. What I'm looking for, dy over dt, is going to equal 8 times x, which is 4, times dx over dt, which is 2, minus 15 times x squared, that's 4 squared, which is 16, times dx over dt, which is 2. And just like that, I'm left with just a simple numerical expression representing the answer I'm looking for. I just have to work it out. 8 times 4 times 2 is 64. 15 times 16 is 240 times 2 is 480. And 64 minus 480 is negative 416. Now, when we get problems with actual context to them, there will be some unit of speed there, feet per second, meters per second, miles per hour, that kind of thing. I wasn't given any context in this problem, so I don't know specifically what the unit would be. But just know that every time you get an answer to one of these problems, d something over dt represents an actual rate of speed. So that's what you're looking to get each time.